Hello world and welcome to another machine learning tutorial. Today we are going to cover the topic ensemble learning, especially therefore we are going to see what is backing and boosting. My name is Harris and let's get started. For more tutorials and content, please hit the subscribe button or leave a like or comment there. Thanks a lot. What are the ensemble methods? First of all, we are going to see what is ensemble learning in general, and afterwards we're going to see what are two methods like bagging and boosting. What are the pros of ensemble learning? You are going to reduce the error. You're going to avoid the overfitting, which you can see in many models. Therefore, you are going to use a majority voting approach. You're going to combine many predictors. And therefore you're going to use a lot of different models to combine the best fit. Ensemble learning is, you can imagine that you have some input data and some output data. You have different data sets which you're going to randomly choose, and you have different models. Let's say you have model 1 is a linear regressor, you have decision tree, and then you have a support vector machine. So 3 different models. You're going to combine them, do a testing and take a prediction and combine them within a majority voting to have a mean of all the output. What is bootstrap aggregation or bagging? Bagging, you can imagine that you have on the left side some data set. You're going to split it within, let's say, training and test data. The training data set you're going to put in, let's say, 3 different data sets or 3 different bags. So it's kind of a bagging. The input data you're going to use, first of all, the first model, let's say regressor. You're going to take a prediction, and afterwards you're going to use a second model and the third model, and you're going to take a mean of the outputs in kind of a majority voting. For example, you have like a classification problem where you have dogs or cats. The first 2 models say it's a cat, and the third model is going to say it's a dog. So the majority voting will say 2 against 1, so it's a cat. A bagging example could be, for example, like this, that you have 2 models and you're going to see what is the ensemble of it. So the ensemble is kind of the mean value of this. So the green line and the blue line are the 2 models, and the ensemble is the red line, which is representing the mean value of it. Boosting or other boost, this is kind of a method. You can imagine that this is kind of some adaptive boosting. Therefore, you have on the left side data set, which we're going to split again into training and testing data. The trained data you're going to use to choose randomly a data set. Afterwards, you are choosing a model, and the model is going to have some weights through this training. You're going to test the data within the training data set. These weights you're going to use for the next model and combine these 2 models or the 2 weights. And you can imagine this like a classification problem where you have like different images from cats, and you're going to predict what kind of cat it is. And then you see after the first model or after the first iteration, you can see that the white cats especially are problematic for a prediction. Therefore, you're going to use the same data into the second data set. So the white cats represented by the red points, and you're going to apply the second model. You're going to test it again with the trained data set, and then take the weights to the third model, and there you have again this white cats where you going to apply the third model, test it again, and then you have again like a majority voting out of the output to have a really good prediction. So a boosting example could be like this, that you have some classifier. In this case, you have 40 classifiers, and then you can see each iteration, the alpha value is going to be less, and you can see that the sample is going to be really good. So yeah, thanks for watching, and please hit the subscribe button if you like the content. Yeah, see you soon.